Alright, so what we're doing right here tonight or today is we're working on multiplying fractions. There's different ways to multiply fractions, or better said, there's different ways to get your answer in simplest or lowest terms at the end. There are 6 ways they go through. First is Rodney. All that Rodney does is he multiplies the numerators together and he multiplies the denominators together. After he does this, um, you're all that Rodney does is he simplifies the fraction. So he comes up with a common factor between the numerator and denominator. And then he looks at that and he tries to keep doing that until the only factor that can divide the numerator and denominator is 1. And when that's the case, then the fraction is in simplest form or lowest terms. So here for Rodney, he multiplied 6 times 9, and then he multiplied 18 times 21. Then he saw that 18 was a common factor for both. After that, he looked at what he had, which is 3 over 21, and he saw that he could divide the numerator and denominator both by 3. And then he got a fraction, the product, the answer, which is 1/7. Now, I don't know about you, but I have trouble seeing what to divide it by sometimes. Dean is similar to Rodney, but he just thinks about it a little bit differently. So he multiplies the numerators together, and then he multiplies the denominators together first. After that, he sees that 54 times 1 equals 54, and he sees 54 times 7 is equal to 78. And then if I look at that, I have 54 over 54. Well, 54 over 54 is the same as 1. So I could cross those off and make them into 1s. Whenever the numerator is the same as the denominator, that's equal to 1. Now, 1 times 1 is 1, and 1 times 7 is 7. So Dean gets the correct answer there. And sometimes, like in that example, it can be hard to see. Remember, in your binder, you have a similar page with the same people with different examples. Ruby does it differently. I like the way Ruby does it. Instead of multiplying them right away, what she does is she thinks of a factor tree. For 6, the prime factorization would be 3 times 2. For 9, the prime factorization would be 3 times 3. For the denominator, if I made a factor tree for 18, it would be equal to 2 times 3 times 3. And if I did a factor tree for 21, well, that would be 3 times 7. Then she looks at what is left. Notice there's a 3 on top and a 3 on the bottom. Well, that's the same as 1. So she can cross those off. When she crosses off the 3, she makes them into 1s. Then there's 2 on top and a 2 on the bottom. She can do the same thing there. She notices there's another 3 on top and another 3 as a denominator, and then one last 3 on top and one last 3 as a denominator. Now if she multiplies those out, 1 times 1 times 1 times 1 is equal to 1, and 1 times 1 times 1 times 1 times 7 is equal to 7. For me, that's really quite simple. I'm good at making factor trees, and that allows me to simplify it in that one step, especially with hard problems like what we have as an example here. Naomi does the same thing as Ruby, but she kind of skips a step, or if I say it differently, she simplifies the fraction before she multiplies. To simplify, you need to divide the same factor from the numerator and a denominator. It doesn't matter which numerator or which denominator as long as it's from a numerator and a denominator. In this one, kitty corner, you have a 9 and an 18. Well, I could divide 9 from both of those because I'm taking a 9 out of the top and the bottom. That's the same as taking 1 out. The same for 6 and 21. You could divide both of those by 3. So they're going to divide them both by 3 because 3 over 3 is the same as 1. So, and now if I look, I have a 2 as a numerator and a 2 as a denominator. Well, that's equal to 1, so I'm just going to cross them off and put 1s there. Now, what I'm left with is 1 times 1 equals 1, and 1 times 7 equals 7. This is a much more efficient way to multiply fractions and get your answer, your final answer, in simplest form or lowest terms. Fifth, we have Joyce. Um, Joyce, in my eyes, is very good at math. So Joyce does what Rodney and Dean did, which is just multiply the numerators. 6 times 9 is 54. And 18 times 21 is going to be 378. Then Joyce magically sees that she could take 54 and 54 out of the answer. So she divides that by 54, it's 1. She divides that by 54, that's 7. And she knows her final answer is 1/7. That's a correct answer, but hard to see. Finally, we have J. J's is very similar to Joyce's. Um, all he does is multiply the numerators together. And after he multiplies the numerators, he gets 54 over 378. And then he does the same thing, but he does it in 2 steps. He sees that he can divide 54 and 378 by 18. And when he does that, he gets 3 over 21. So he's not quite showing it the same as Rodney was, but it's the same idea. And then he gets 3 over 21, and he sees he can divide both of those by 3. And so he just crosses them off and puts what that would be. And then that's his final answer, so he says it equals 1/7.